We know that if we want to convert a JK flip-flop into a D flip-flop, all we have to do is JK and Q bar, and there is clock. So all we have to do, we have to connect an inverter between J and K inputs, and J becomes the D input basically. So this becomes the D flip-flop. But if we want to convert a D flip-flop into a JK flip-flop, let's imagine that we have to do that. So Q here, Q bar, we have a DK flip-flop, we have a D flip-flop, but we want to convert it into a JK flip-flop. So what we will have to do, there will be a combination of gate here which is unknown. There will be J input, K input, and the output fed back here. All these three, there will be a combination of J, K and Q, and that output will go into T as input for the D as input, and this block will be the JK flip-flop. So what will be the combination? In order to know that, let's write down the truth table of JK flip-flop, the one that we want it to convert into. So this is QT, Q present, also can be said Q present, and this is Q next state, present state, next state, and Q, it's also can be stated as QT1. I think I wrote QT1 in one video. It's more conventional to write QT plus 1, and this is at QT. So present state here, next state here, JK. So 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. These are the 8 possible combinations. So when both are 0, we can see that these two and these two, when J and K are the same, these are as T flip-flop, and these 4 inputs as D flip-flop. We know that. So when both J and K are 0 and Qt is also 0, that means there is no change. If we think in terms of T flip-flop, no change, so this will be 0. Similarly 0 0, this is 1, no change, so this will be 1. When 0 1, it is acting as a D flip-flop, and the D flip-flop is J flip-flop, J input, D input is J input, sorry. So this is 0, output will be 0. When 0 1, this is 1, present state is 1, next state will be 0 because this is 0. When 1 0, present state is 0, but next state will be 1 because this is 1. 1 0, present state is 1, but next state will be 1 as well because this is 1. J is 1 basically. 1 1 again will act as a T flip-flop. 1 1 means toggle mode, so present state is 0, next state will be 1. 1 1 again toggle mode, present state is 1, next state will be 0. So this is completed. Now we should write the column involving D input. So what D input will produce this present state and next states basically. What D inputs will produce the present states and next states, these ones basically, these two columns. So what will happen, since we are talking about D input, whatever is at D input goes to the next state at the output. At the output, next state becomes the D input. So we can just copy this column, the next state column, into the input, because with clock the input goes to the output. So 0 0 1 1 1 and then 0. So our D input will have a function of J, K and Qt. So we have to figure out what is that. So looking at the truth table, what we have to do, this, since there are 3 variables, we should be better off using a K-map. So I'm drawing a K-map here. 3 variable K-map. So this is J, J bar J, K bar Qt bar, K bar Qt, K Qt, and then K Q T bar, or I can say I will use a different color, maybe green here. 0 1 0 0 0 1 1 1 and then 1 0. So we should identify the ones at D column at the output. So D here, there's a 1 here, 1 here, 1 1 here and 1 1 here. There are 4 ones. So this one corresponding input is 0 0 1 0 0 1. So 0 0 1 will be 0 and 0 1. So this one, this cell. Then this is another one which is 1 0 0. So 1 0 0 will be 1 here and then 0 0 here. So this cell basically, because this is 1 here and then 0 0. Then this one, which is the third one, it is 1 0 1. 1 0 1 is 1 here and then 0 1 here. So this one. Finally this one 1 1 0, because this is 1 1 0. So 1 and then 1 0, that is that one. So what we should do, we should we can form two groups. One is this one, another is this one. When I look at this group, the expression will be for this one K, sorry, that should be K bar here, K bar QT. And this will be the other group. This one is J QT bar, J QT bar. So we get J QT bar plus K bar QT as the input of D flip-flop. So if I draw it again, maybe I can go back to the original one. I will draw it again here. So this is my D flip-flop. With D input there is the clock here, and then we have Q here, Q bar here. So J and K I want. So J QT bar. So QT bar can be this one. So let's bring it here. J QT bar ANDed, and then Q bar T. Sorry, K bar T. K bar inverted times QT. Sorry, K bar QT. So K bar and QT. So this can come here, and so this one, of course, an overlap here. This and output will be ORed, and then the OR output is gone as an input to D. So this is, here we have J QT bar, and at this AND gate we have K bar QT, and here at the output of the OR gate we have this one. Basically I can ignore, sorry, this one, yeah. So that's what we have. This one is at the output of the OR gate. So this is our JK flip-flop basically, and the clock is of course the same clock, and we have converted the D flip-flop into a JK flip-flop.